Recall our goal. Our goal was to understand the exponents of or the coefficients of higher powers of a binomial, which is this. So if I have a plus b, I get a plus b. A plus b whole squared, I have 1, 2, 1, right? So you think of this as 1, 1. This is 1, 3, 3, 1. Then I have 1, 4, 6, 4, 1. And then I have 1, 5, 10, 10, 5, 1. The power of a and b, when you add them, let's say the sum of powers of a and b equal n, right? 5, 4, 1, 3, 2. Next thing is power of one of the terms decreases. It goes from 5 to 4 to 3 to 2 to 1 to 0. And the powers for b increase from 0 to 1 to 2 to 3 to 4 and then to 5. And the coefficients are given by this formula. So if you have a plus b to the power n, then this that we learned to evaluate in the previous video give us a coefficient. So n0 gives me the first, n1, n2, and lastly nn. Okay, let's try this for x plus 2 to the power 4. So this says right there, that's my n. Let's say that's my a and that's my b. So what I have is 4, 0, x to the 4 plus 4, 1, x to the 4 minus 1, so cube 2. 4, 2, x squared 2 squared. I keep going till I reach 4 on this bottom number. X 2 cubed, 4, 4, nothing for x, and 2 to the 4. Now, let me evaluate these things. 4, 0 is 4 factorial, 0 factorial, 4 factorial, which is 1. 4, 1 is 4 factorial, 1 factorial, 3 factorial. That's 4 times 3 factorial over 3 factorial, so it's 4. 4, 2 is 4 factorial, 2 factorial, 2 factorial. That's 4, 3, 2, 1, 2 times 2, which is 6. 4, 3 is 4 factorial, 3 factorial, 1 factorial, which we already found is 4. And then lastly, 4, 4 is 4 factorial, 4 factorial, 0 factorial, which is 1. So the coefficients are 1, 4, 6, 4, 1. So I have 1 x to the 4 plus 4 x cubed times 2 plus 6 x squared times 4 plus 4 x times 8 plus 1 times 16. That's x to the 4 plus, I can combine these numbers as 8x cubed, combine these as 24x squared, combine these as 32x plus 16. So you don't have to do all the complicated multiplication in order to get an expression for x plus 2 to the power 4. Now let's look at another example, 2x minus y to the 5. Now let's strategize this in order to make it easier. So if there is a negative, if you have a minus, then the terms alternate between positive and negative. So this is going to end up being something minus something plus something minus something plus something. Now you know that you have to evaluate these things. Now 5, 0 is going to be 1. 5, 1 is 5 factorial, 1 factorial, 4 factorial, so that's 5. 5, 2 is going to be 5 factorial, 2, 3, that's 5 times 4 times 3 factorial, 2 times 3 factorial, give me a 10. 5, 3 is going to be 5 factorial, 3 factorial, 2 factorial. That's the same as the one I found just now. 5 4 is 5 factorial, 1 factorial, 4 factorial, which is 5, and 5 5 is 5 factorial, 0 factorial, 5 factorial, 1. So I know these numbers are 1, 5, 10, 10, 5, 1. Now I know that the powers of this starts from 5 and then it's going to go to 4 and 3, 2, 1, 0. For this one, it's going to start from 0, 1, 2, 3, 4, 5. So first I have 1, then I'm going to have 2x to the power 5. And then it's going to be minus because of the negative, it alternates. The next coefficient is 5. The power of 2x is going to go down by 1. And I'm going to have 1 power of y. Then it's going to be a plus with the next number. 2x, power reduced by 1, power of y goes up by 1. Then I have a minus 10, 2x squared, y cubed. And I have a plus 2x, y4, and lastly I have minus, and in this case it's 1 times, no more 2x term, y to the power 5. So this question also is on your worksheet. On the worksheet you can complete this by actually performing these operations and simplifying all possible the numbers into one single number for each of them. Okay, in the last video we're going to look at how you can make these calculations way easier by looking at something called a Pascal's triangle.